The first thing we would like to talk about today is feature-based machining in both VisualCAD CAM and RhinoCAM 2018. There's been numerous enhancements and new features that have been added to feature-based machining. So the first thing I'm going to cover here is automatic feature detection and automatic feature machining. So these can be found under the Machining Objects browser on the tab called Features. You have several additional options in 2018. The first one we're going to talk about is automatic feature detection. So selecting automatic feature detection automatically analyzes and identifies all the different features from the solid model that you're working on. So with just a single button click, you will see that all of the features have been identified and automatically identifies the features for all the different orientations that you have. So in this particular part there's two possible orientations you could program this part from. So there's one from the top and one from the bottom, and there's two orientations, and as you expand the tree for each orientation, you'll see that there are several different features identified based on the part that you have for each of these orientation in here. Now once you have these features identified in here, we've now introduced a single button click to automatically program machining operations to these. So you just have to select automatic feature machining under the Features tab, and in this process you will notice that it automatically generates the toolpath for each of these features. So we have a facing operation program for the open pocket. For closed prismatic pockets, you could program pocketing, slot machining for slot features, profiling, drilling, and chamfer operations. Now you could establish a knowledge base and have them associate to these features. That's how you can automate this to a single button click for feature, automatically programming for these features. So this is called AFM, automatic feature machining. And what we just looked at earlier was automatic feature detection, which would be AFD. Now we also have interactive feature machining as well, detection and machining. We'll get to that in just a moment. So once I have these features detected in here and programmed, I'm going to run a quick verification. So I'm going to hit Simulate, select the Play option under the Simulate tab, and you'll notice that we've completely programmed the part by just two button clicks. One click to identify and detect the features. The second click is to automatically program the toolpaths with these using feature detection and machining. Now let's go back one step and graphically analyze some of these features and see how we can program it. So since we already identified these features in here, as you hover your cursor right on top of each of these features, you will notice that the corresponding features are being highlighted on the part. So if you just hover the cursor over it, you'll notice that it identifies the feature as a prismatic pocket. You could now perform a right mouse button click on these features, and this will automatically let you choose the operation type. So if you do a right click, so for the closed pocket, what I've selected, I could either be programming a pocketing or a profiling operation. So now I could pick pocketing in here, and this automatically adds the feature to the operation. You could then make a selection for your tool, establish your cut parameters, and you'll also notice that the cut levels are automatically established based on the feature. And you can see that the depth per cut is automatically established. So all I got to do is hit Generate, and the toolpath is now generated. Now if I go hover the cursor right over a slot feature and perform a right click, you will notice that the operations that you can program for a slot feature are automatically identified. So it automatically filters out the operation and identifies the best technique or best method to use for programming these features. So right click, and now I can select slotting. And once you made your choice for the tool, establish your cut levels, you'll notice that all of these parameters are automatically populated based on the feature that was identified. And then if you need to change or adjust any of the slot parameters, you can do that and then pick Generate to program the toolpath. Now finally, we want to program this, the open pocket in here. So I'm going to right click on this, And you'll notice that for an open pocket, I could rough it out with a facing operation and then go back and finish it with a profiling operation. So I could right-click and choose facing. Again, the feature is automatically selected. You make a selection for your tool, establish your parameters for roughing, and then you'll see that the cut levels automatically has the depth established from the feature, and then you have your depth per cut automatically filled in as well. So selecting generate will create the tool paths for you. So you have the facing, slot machining, and the pocket operation. So this is interactive feature machining where you can interactively graphically select the features from the model and generate the tool paths. Now, this took a certain amount of time. We had to interactively program each feature. Now, the automatic feature machining makes it a lot faster. So once you have your knowledge base established, it would be just a single button click. So you just highlight the orientation and then click on automatic feature machining, and you'll notice that in just a single button click, you're able to program each of these features in here. You have your drill, pocket operations, slot, facing, all of the operations are automatically programmed with a single button click. Now I'm also going to go ahead and show this to you in our VisualCAD CAM product as well. We'll take a look at another example and see how we can identify some of the other feature types as well. So again, in here I also have a prismatic part. So I'm going to go into the Features tab, and you can either do automatic feature detection like we did on the other example, or you could interactively identify features, and you can just pick faces from which you would want to identify the features and then perform a right mouse button click, and it'll automatically identify the features for each of the orientations. So we now have identified features for 3 different orientations: the top, the front, and the right faces. And as you expand this, you'll see that there's a planar face and a slot feature identified for the front, and there's also a hole feature, a planar face and hole feature identified in here. So to program these operations, you could either interactively select the feature, right-click, and program it. So in this particular case, I have a stepped pocket feature, and I can still program the step pocket using a pocketing for a roughing, and then go back and finish it with a profiling operation. So I pick pocketing in here, make a selection for the tool, establish the parameters, and then pick generate. So we now program the step pocket feature in here. So there's several different types of features we can identify in 2018, and I'll give you a list of different features. Now, in addition to the features, we have a feature report in here where you can list all the different feature types. It lists and gives you all the feature properties and parameters for it. So when you click on list features, it basically gives you information about each and every feature that have been identified on the part. You can also hover your cursor over each and every feature in here, and it automatically identifies the depth and the diameter. For example, for the whole feature that we identified in here, you will notice that you have a depth of 0.262, and then it also establishes the min and the max diameter for each of these holes. Now as I switch back to the other part here in RhinoCAM, you will notice that when I hover the cursor over the prismatic pocket, it identifies the depth and the information about a preview about what type of feature it is in this particular case. So this gives you a preview information about the feature, so you could basically adapt whatever cutting strategy that you want to use and the tool that you'd like to select for it. Now the next thing I would like to show is the type of features that we can identify in our 2018 version. So we can identify whole features, prismatic pocket features, open prismatic pocket, boss features, general 3D pocket features, which could be programmed using 3-axis operation, slot features, open slots, T-slot, V-slot, general pocket for 3-axis, planar face, fillet, chamfer features, and step pocket. So these are some of the additional new types that we've added for our 2018 release, in addition to some of the feature types that we had in our previous versions of the product. Folks, at this point of time, if you do have any questions about feature detection and feature-based machining, please feel free to post those questions and we'll try to get them answered for you.
I just want to jump in here. This is Joe. Just a little note about the feature-based machining. The first thing I want to emphasize here is if you've noticed, Uday, when he did the interactive feature detection, not detection, but machining, he had to pick each of the feature and actually create the operations. And I was timing him, and it took him about 3 minutes to create 4 or 5 operations, which is not bad, which is actually pretty good compared to the previous ways of machining where you actually have to pick the edge curves and select the depths automatically, or not automatically, but actually have to figure out the depths, go pick the depths and all of that. And all of that in the interactive feature detection and machining has been removed. And so you're able to machine relatively quickly. 3 minutes for 4 or 5 features is actually quite good. But then if you take that one step further, where he did the automatic feature machining, it was just a couple of seconds. I mean, he did talk for a while, but just 2 button pokes, a couple of seconds, you got toolpaths for the entire feature model. Yes, you have to do some setup work first, but once you set everything up in the terms of knowledge bases and all that, you can generate toolpaths very efficiently and very quickly. And so this has been our focus for the 2018 product, and will continue to be a focus for the coming versions. More automation, and you probably heard Uday say automatic about probably 20 times. I counted more than 20 times. And that's really been our focus for the 2018 and also for the future products as we move into 2019 and further. We're going to be introducing additional features, feature types, and turning as well. So this is the future of CAM here, people. So this is really exciting for us, and I hope you see the promise in the things that we're showing you today. Thank you, Uday.
Thank you, Joe. Folks, the next topic we would like to cover today is enhancements to our flagship VisualCAD CAM product. So we're going to talk about some of the enhancements that have gone into VisualCAD. There's been numerous enhancements, but we'll only be able to cover a few of them during this webinar today, but you're welcome to take a look at the What's New document. So that'll give you the list of all the enhancements. So one of the very nice enhancements in VisualCAD is being able to select selecting a chain of curves or chain of surface edges for programming a toolpath. So for example, a part like this here I have loaded on my screen has several edges that I need to select for programming a toolpath. I can be selecting a chain of curves or chain of face edges, and this can be done automatically by just holding down the shift key, and you can either pick a curve or a surface edge, and you will notice that it automatically selects an entire chain. So it makes your workflow selection process a lot easier and faster without having to go through and manually select each and every face edges. Now you can also select multiple of these by just holding down the shift and the control key, and I can go back and select another edge, and you'll notice that it automatically selected both the chain for the interior. We also were able to select for the exterior of this particular part. So this is one of the very nice enhancements in VisualCAD where you can make your workflow a lot faster, being able to select a chain of curves, or you can select a chain of face edges or surface edges from your solid surface geometry that you're working with. Now, the next thing I would also like to go over here is being able to take advantage of pre-selection highlight, and we'll also talk about a ghosted display in VisualCAD CAM as well. So to go over the pre-selection highlight, I'm going to go ahead and pull in another part in here. And in this particular case, you'll notice that as you hover the cursor around the part, it automatically pre-selects or highlights the geometry. In this particular case, this part happens to be a solid geometry, which is a poly surface, so there's only one geometry to highlight. Now, if I go over to the solid modeling tab and explode this model in here, and you'll notice that now I can easily pre-select as I hover over the geometries in here. It automatically pre-selects and highlights the corresponding surfaces or the face edges from the part. So this makes it a lot easier for you to make your selections in VisualCAD, and that's a great tool. That's a great enhancement that you can see in VisualCAD CAM 2018. Now the next thing we would like to talk about is the ghosted display option. This is an additional option that you'll find in VisualCAD CAM 2018. In addition to the other display modes, we now have the ghosted display mode. So in this particular mode, you'd be able to view features like cavities on this part, which is hard to see in a typical standard shaded display mode. You can switch from the shaded mode to the ghosted display mode from the heads-up display toolbar right on top of the viewport, or you could find it under the display tab in here. You can click on ghosted display to switch to the ghosted display mode. This is also one of the many enhancements that you will find in VisualCAD 2018. Folks, again, if you do have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them to you.
There's a few other enhancements in VisualCAD, like rotation of a model by 3, selection of 3 points. A lot of these enhancements in VisualCAD were a result of user requests, and we're not going to show you all of that, and you can actually read that in the What's New document, the PDF link that I just sent out to everybody in the chat window.
Thank you, Joe. Folks, the next thing we're going to cover here is the general CAM enhancements for 2018. And first, I'm going to talk about surface selection. That's a very nice feature in 2018, and this is available in both VisualCAD CAM as well as in RhinoCAM. So surface selection allows you to select individual faces or surfaces from a solid geometry without having to go and explode the solid model into individual surfaces. So even though we have a solid model in here, when you're programming a 3-axis operation, you could go into the Part Surfaces tab, and you could individually select surfaces that you'd like to use for machining. So you don't have to explode the model, so you can individually pick the surfaces. And once you make a surface selection, you can perform a right mouse button click, and you'll automatically notice that those surfaces that you selected are highlighted and added to the selection list, and you can generate a toolpath. So you don't have to explode the solid model, and you can go directly, just select individual surfaces in here and generate your toolpaths for surface selection. So I have just a handful of surfaces selected in here, and you'll notice that the toolpaths were generated for those surfaces that you selected. So without having to explode the solid geometry into individual surfaces, you could do a surface selection. Now the same functionality is also available to you in RhinoCAM. So you can go into your machining operation, go to Part Surfaces, and you could individually select surfaces in here for machining. So from a poly surface model, without having to go and explode these geometries in here, you could graphically pick those surfaces from a poly surface geometry, perform a right mouse button click, and then pick Generate to compute the toolpath. So this is also a very nice enhancement for being able to select individual face or surface from a solid geometry. The next thing I'm going to cover here is the ability to suppress and unsuppress machining operations. That is also a nice feature which is offered in our mill module, and it's also available in our CAM products in here. So to demonstrate this, I'm going to go over to this example we looked at earlier, and to be able to suppress an operation, you could just select an operation, or you could select a machining operation set or entire setup and perform a right mouse button click on it, and you'll now see that there's a new option to suppress it. Now when you suppress an operation, the suppressed operation will be excluded from being simulated, from being post-processed, and regenerated as well. So you could suppress one or more operations, so you can lock them in place and not having to post them or simulate them. So this is a very nice feature, again, available in 2018. So you could suppress it, you can go back and right click to unsuppress it. So as you suppress the operation, the suppressed operation cannot be either post-processed or you can exclude it from being simulated and being regenerated as well. Now, one of the other enhancements I would like to talk about here in 2018 is the ability to toggle the toolpath display in hidden areas. Now, the part that you're looking at here displays the toolpath, but there are several areas of the toolpath that aren't visible because of the shaded mode of the solid model, shaded display of the solid model. So to see the toolpath in those hidden areas, you could select toolpath hidden area display, and this is a new option which is available in 2018. And as you toggle this, you'll be able to actually look through the toolpath from the hidden areas as well. So you can just the single button click to toggle it on or off. Similar to your toolpath display, you have the option to toggle the display of the hidden areas. And this is also a new feature available in both VisualCAD CAM and RhinoCAM 2018. Folks, again, if you do have any questions on these general CAM enhancement, please do post these questions in the questions panel, and we'll do our best to answer them for you. So the next thing we would be covering is enhancements to our 2.5 axis machining operations. And we'll cover several different enhancements. And the entire list of enhancements, again, can be found in the What's New document. So you're welcome to take a look at the What's New document. We will be covering a few of these enhancements in here today during the webinar, but you can review the entire list by going to the What's New document in here. Now, one of the enhancements that I'm going to cover here is enhancements to chamfer operations that is added to a 2018 release. Now, as you select a chamfer operation from the 2-axis methods, you will notice that under the Cut Parameters tab, we've now added the option to specify the chamfer either as height or as width. So you could now also specify height, and it'll automatically establish the width for chamfer operations. So this is available in 2018 version, both in VisualCAD CAM and also can be found in RhinoCAM on all chamfer operations. The next thing I'm going to talk about is enhancements to high-speed cut pattern toolpaths. There have been several enhancements made to the high-speed cut patterns, and one of the enhancements that we're going to talk about is the toolpaths have been made more robust, and in certain cases where we had identified some issues with the toolpath in the earlier versions, they've been addressed in version 2018. As you can see, here is one of the examples where the high-speed cut pattern may have failed in some of these areas, and these have been addressed in 2018. So in certain test cases where we had noticed some issues, they've been addressed and they're much more robust in 2018, the enhancements to high-speed cut pattern. The next enhancement we're going to talk about is the order of cutting in engraving operations. And for that, I'm going to go ahead and switch over to RhinoCAM to give you an example for the ordering of the in a sequence of operations in RhinoCAM, and then we'll also talk about the enhancements to bridges and tabs as well. So what I have here is basically some curve geometries. This is actually a single line font which you can create in both RhinoCAM and VisualCAD CAM. And in 2018, the order in which these the toolpath follows these curves are automatically sorted out. So in the previous version, as you can tell, it used to sort the open curves first before processing the closed curves. As you notice here, from the previous versions, you see that there's more retract motions and transfer motions occurring in here, and these have been streamlined to version 2018. So it's a lot more uniform, so they're processed in the same order. So this makes it a lot more efficient and eliminates the additional transfer motions that were involved from previous versions. Now, we also made enhancements to bridges and tabs in our version 2018, and I'm going to go ahead and give you an example of that in a profiling operation in here. So in 2018, we've now added a new option under bridges and tabs where you can reduce the feed rate on descending motion. So this will allow you to reduce the feed rate by 1% of your cut feed rate, and this percentage of your cut feed rate can be set under the feeds and speeds tab under plunge between levels. So for example, if I set the feed rate to be 10% of the cut feed rate, now as the cutter retracts over for a bridge and then plunges back in, it applies a percentage of your cut feed rate that you specified. So it'll reduce the feed rate for every plunge motion across as it travels across each and every bridges and tabs. This is a very nice enhancement for bridges and tabs that you'll find in version 2018. Again, folks, if you do have any questions at this point of time, please do post those questions in the questions panel, and we'll be more than happy to get to those questions. And these are just a few of those 2.5-axis enhancements that we have in our 2018 version. One of the other enhancements I would like to talk about in 2.5-axis is a brand new toolpath method called fillet machining that has been introduced, and I'm going to go over that as well by taking an example in VisualCAD CAM. So filleting is a new operation that we've introduced in 2-axis machining, so you can find it under the 2-axis methods, and this would be available right from our standard configuration. You'll find the filleting operation, and you can specify a fillet mill tool for it to program fillets like these on the part that we have by specifying either in a solid model, or you can work with just a 2D geometry, and you can define a fillet mill tool for this application in here, and you can specify a fillet mill tool with the corner radius for the fillet, and you could program and simulate the tool path it shows with the fillet mill on it. And the fillets are generated, and you can simulate it with the cut material simulation with the fillet mill. So these are just a few of the many enhancements that have been added to 2.5-axis operations. Now, at this point of time, I'll just pause for a brief second to see if you have any questions, and then we will move on to our enhancements for 3-axis.
Yes, one thing that they pointed out again is all of these enhancements again are in the What's New document. You can refer to that link that I posted, and in addition to these new functions and features that we have added, there's a lot of work that has gone in to make some of these toolpaths more robust and fix bugs in terms of what our customers have sent us in some cases. So overall, this 2.5-axis is a very robust and a very production-ready product right now in the 2018 version.
Thank you, Joe. So the next thing we're going to cover here is enhancements to 3-axis machining. Again, these enhancements will be available right from our standard configuration in the 3-axis. So the first thing we're going to talk about is the enhancements to horizontal finishing operation. Now currently in version 2017, for the horizontal finishing operation, by default, when it used to retract to a clearance plane when a containment is encountered. So for in an example in this case like this here, you were noticing that the cutter used to retract and then step down to the next level when you had a containment over here. Now in version 2018, we've introduced a new option in here which allows you to follow a containment. So you have this additional option that's called follow containment, and this is available in all the configurations starting with standard. So you can choose follow containment, so this will eliminate the additional retracts and transfer motions and basically use your same cutting feed rate as it follows the containment across. And this makes it a lot easier for machining and eliminates the need for acceleration and deceleration and makes it a lot more efficient and smoother. Now here's an example where you'll see that how the benefit of follow containment helps on a typical case. In this particular case, you see that there are several areas on this part with the containment where it's following the containment versus retracting it to the clearance. So this eliminates a lot of additional transfer and retract motions, and with the follow containment, it makes your cutting a lot more efficient. So this is one of the many enhancements that have been added to 3-axis machining in version 2018. The next thing I would like to talk about is enhancements to steep Z finishing, and this method is available in the Pro and Premium configurations of our mill module. So if you go into 3-axis advanced and select steep Z finishing, we've now introduced the option to specify top and bottom cut containments, and you can either use the spinner increment controls, or you can graphically pick the top and the bottom cut containments for horizontal hill machining, or also known as steep Z finishing, and this is available in version 2018. And this particular method, the horizontal hill machining or the steep Z finishing, is available in Pro and Premium configurations of our mill module. Now the next thing we would like to talk about is the enhancements in 3-axis for sorting of regions in parallel finishing and also 3D projection pocketing. And to go over this, I'm going to bring in another example in here, and we'll take a look at how we've been processing currently in our previous versions. As you notice, there are several retracts occurring in here as it transitions from one containment region to the next in the case of parallel finishing and 3-axis projection pocketing. Now with our version 2018, we've introduced the sorting tab, so that will make this sorting between containment regions either based on a minimum distance sort or based on a directional sort, so it makes it a lot more efficient as the cutter transfers over from one containment region to the next. So you can take advantage of the sorting tab in parallel finishing, and this is available again in our mill module starting with the standard configuration, and the 3-axis projection pocketing is available in our Pro and Premium configurations. So the ability to sort your control geometry or containment regions is one of the many enhancements that have been added to 3-axis machining operations. So we talked about the enhancements to horizontal finishing, steep Z finishing, and also sorting of regions in parallel finishing and projection pocketing. Again, folks, if you do have any questions at this point of time, please do post those questions in the questions panel before we move on to the next enhancement topic. Okay, so the next topic we will be covering here is our enhancements to 4-axis methods, and this would be available in starting with expert configurations of both VisualCAD CAM and RhinoCAM in 2018. And to go over this, I'm going to bring in this part where we're going to talk about 2 different enhancements in 4-axis. Now there's a new 4-axis method that's been introduced, which is called create round operation. And in typical 4-axis applications, in woodworking applications, for example, where you're starting out with a rectangular blank, in most cases, you'd want to turn the rectangular blank into a cylinder, so you want to eliminate those sharp corners around the rectangular blank. So we've introduced a new operation called create round or create cylinder under 4-axis, and with this operation, it'll automatically identify the stock that you've defined, and based on the part, it will create a toolpath to create a round stock out of a rectangular block that you're going to be starting with. And I'm going to run a verification in here, and you'll notice that this method automatically can be used for creating a round stock out of a rectangular block that you'd be typically starting with. So this is a very efficient way to rough it out, and then you can program additional operations like pre-finishing and finishing operations for parts that you're going to be starting out with a rectangular blank. Again, this is one of the several enhancements that have gone into our 4-axis toolpaths, and this would be available right from our Express configuration of the product. Now the next enhancement I'm going to talk about is a helical cut pattern that we've introduced in 4-axis, and this is available in 4-axis parallel finishing operation. And as you go over to the cut parameters tab, you will now notice that there's a new cut pattern that's available. That's a helical cut pattern. So this will allow you to constantly cut while it's rotating, eliminating the need to retract between each step overs. And this is a very efficient way to continuously cut as it follows along the 3D model. And as you can tell by looking at the toolpath here, it creates a continuous helical cut pattern, and it follows the geometry that you're trying to program. Again, this feature, the helical cut pattern, is offered right from our expert configuration in RhinoCAM and VisualCAD CAM 2018. Again, folks, these are a few of the several enhancements that I'm previewing here in the webinar today, in the What's New webinar. So you can take a look at the entire list of enhancements by referring to the What's New document. If you do have any questions, please feel free to post those questions in the questions panel, and we'll try to get them answered for you. The next enhancement we're going to talk about is enhancement to our 5-axis module in here. And I'm going to bring in a couple of examples in here to go over that as well. And we'll take a look at some of the enhancements to our 5-axis toolpath methods. Now, one of the new enhancements that we've added in 5-axis methods, and this option is available in our premium configuration, we could now lock one of the axes in 5-axis to a 4-axis. So, and this is available in all of these methods except the drive curve machining. So as you select one of these methods, you will notice that under cut parameters, you now have the ability to lock it to a 4-axis versus programming a full 5-axis or a true 5-axis. Now, a lot of parts similar to these can be programmed on a 4-axis machine using the true 4-axis method. So the 5-axis toolpath methods that you see here now offers you the ability to lock one of the axes in, so you can program this as a true 4-axis operation in here by locking one of the rotational axes in here. So you'll now notice that the tool remains normal to the rotational the surface being machined by locking one of the axes in here. And I'm going to go ahead and run a verification in here on this particular operation, and we'll switch over to one of the side views. So you will notice that the tool motion, by looking at it, you can tell that it's locking one of the axes in. So you can program this as a true 4-axis, so you don't really need to have a 5-axis machine tool, but you can accomplish these on a 4-axis machine by taking advantage of this ability to lock one of the axes in our premium configuration of the product.
Yeah, this actually opens up an entire class of parts that you can machine. Things like what they're showing here, handrails with twisted handrails for staircases and things of that sort, chair handrails. A lot of furniture makers use this kind of geometry shapes, and you don't need to have a 5-axis machine. You can machine these now with these options that we have put in for, I believe, the 5 methods there in the 5-axis panel. So quite a few methods for you to utilize on your 4-axis machine. You don't need a 5-axis machine to use our premium product anymore. Thanks for that.
Thank you, Joe. Folks, the next thing we would like to talk about here is enhancements to holder collisions, and we'll also talk about feeds and speeds enhancements, and also we'll cover enhancements to the tapping operation in both VisualCAD CAM and RhinoCAM 2018. Now, the first thing I'm going to cover here is an enhancement to the holder collision. So in 2018, in addition to being able to mark the collision areas during simulation, we're also marking the collisions with the tool motions and also flagging the operations in here as dirty. So you'll notice that as I simulate this pocket operation in here, when a holder collision is detected, it automatically flags the machining operation as dirty, as you just noticed it, and as you take a look at your toolpath viewer or the toolpath editor, it also marks those corresponding tool path motions as flags them in as collision areas in here. So you can graphically identify those, and you'll notice that the collision areas are also marked during simulation in here as well. So this is a very nice enhancement for you to, in addition to being able to view those collisions in the simulation, you can actually go and look at those specific toolpath motions in your toolpath viewer or toolpath editor, and it also flags the machining operation as dirty, so you can see those being reflected for the holder collisions as you identify those holder collisions during simulation. So this is a very nice enhancement that you can see in version 2018, and this can be found right from our standard configuration. The holder collisions can be identified. The next thing we would like to take a look at is the enhancements to feeds and speeds in 2018. So I'm going to go over to the Feeds and Speeds tab and select Load from File. We've now introduced the option to set a maximum spindle speed and a maximum cut feed rate. And this is available in both our mill module and also in our turn module as well. So you can establish the maximum spindle speed that can be handled by your machine tool in here. And you can also establish the maximum cut feed rate. So once these parameters are established, these parameters will be saved, and it'll automatically pull in those parameters on the next part or the next job that you're programming. So it honors the maximum spindle speed and the cut feed rate that you specified in here for the operation. So this is one of the enhancements that you can see under for feeds and speeds. The next thing we're going to cover is the enhancements to our tapping operation in here. Now we've introduced a brand new method in tapping, which allows you to specify as a peg tapping operation. So with the peg tapping operation, you can now specify a peg depth, or like your depth per cut, similar to your peg drilling. You have a peg tapping operation in here where you can specify these parameters, and the post processor can be configured to output the cycle for peg tapping as needed. So again, this is one of the enhancements that have been gone into a whole machining operation. Under tapping, you'll find a new tap type as peg tapping, and this is available in all configurations, starting with standard configuration of our mill module in 2018. So this gives you a brief overview of some of the methods and enhancements that we have introduced in 2-axis, 3-axis, 4-axis, 5-axis, and also we talked about enhancements to VisualCAD, General CAM enhancements, and feature-based machining. The next thing we're going to talk about is a brand new module that is being introduced in both VisualCAD CAM and RhinoCAM, and this is called the Mesh module, and I'm going to go over this with you in just a moment. Folks, before I get started with that, if you do have any questions with any enhancements to our mill module with any of the topics that we covered during this webinar, please do feel free to post your questions and we'll try to get them answered to you.
Yeah, what Uday is going to be showing next is our Mesh module. As he says, it's a brand new module, and it finds applications if you're doing a lot of reverse engineering, and if you're doing if you're getting STL files for machining, which some of our customers actually use STLs for mold making, and you want to actually clean up the data or create meshes out of point clouds, it's quite useful for that. And also it has 3D print applications as well. So basically we have taken a lot of the core functionality from our 3D print product, and because a lot of our customers have requested that mesh functionality, so we've added that as a mesh module here. So thanks, Uday.
Thank you, Joe. So we're now going to talk about the brand new module that we're introducing in both VisualCAD CAM and RhinoCAM 2018. Now this module can be added on to any of your configurations, and you can access the Mesh module by just going up to the menu under the CAM menu, and then you can select Mesh. You'll now see that the Mesh is now an option available right under Mill and Turn. So as you select the Mesh module, it automatically displays the interface interface. The browser, very similar to how you're familiar with our mill and turn module browsers. You'll see that the mesh module also has a browser-driven interface. So the mesh module has a wide range of applications in here. So you could be working with a point cloud data, which could be generated from a 3D scanning device, and you could take the point data and convert it to a mesh, and you can use it for downstream applications, which could be milling or it could be 3D printing. We also have the ability to take a solid surface model and convert it to a mesh, so you could perform additional mesh modeling tools like mesh Boolean, where you can unite meshes, do mesh subtraction, intersection of two meshes. You can also do splitting and offsetting of meshes as well. And we also have slicing as well in here. So there's a lot of tools under the modeling tab in the mesh module. And then under the inspect and modify tab, one of the nice features that you can see is decimation in here. So decimation is reducing the mesh count or reducing the number of polygons or triangles in a mesh. So it makes it a lot easier for you to generate toolpaths. Now sometimes when you bring in a scan data, you could have millions of polygons or triangles on it, and it could be very hard to machine such a large data. So you can easily decimate the mesh using the reduce mesh functionality in here. You can also do a remeshing and mesh smoothing as well, that is available to you under the inspect and modify tab as part of the mesh module. And you can also individually use the manipulation tools in the mesh to modify the mesh. And then the repair tab offers several additional functionalities. If you have a mesh that is not closed, you can perform stitch and close to join several open meshes. You can perform an auto fix, which can automatically identify holes, gaps, self-intersections, incorrectly oriented triangles, automatically fix those, and we have additional tools in here as well. Now I have a part loaded in here, and as you can see, there are some gaps and holes on this part. So to fix these manually, it's going to be a time-consuming process in here. So we're going to take advantage of this feature called auto fix, where it can automatically fix meshes for holes, gaps, and self-intersections. You just have to pick the mesh and right mouse button click. You'll notice that it automatically fixes the mesh geometry in here. So once you have the auto fix performed on it, you can go back and run a diagnostic check to see if you identify any issues in here. So you can check for open edges, short edges, several different options in here, and you can see that there weren't any issues identified after the auto fix is performed. Now once you have the mesh prepared, it's now ready for your downstream application. And in this particular case, since we're using our VisualCAD CAM application, I'm going to go ahead and switch over to the mill module, where we can actually program some toolpaths in here. So once we have the mesh prepared, we can go into 3-axis machining, and I'm going to choose a parallel finishing operation in here, and I'll switch over to the tool tab to make a selection for the tool and program a toolpath. So we've imported an STL file, we've analyzed the model, we prepared the mesh, we fixed the holes and the gaps in the mesh, and now we switched over to the mill module to program some toolpaths in here. So now I'm going to go ahead and run a verification of the toolpath which is generated with the mesh module. So the mesh module makes a great add-on module for your existing VisualCAD CAM mill module, which can help you in fixing mesh geometries that you're working with, like STL files or point cloud data, which you can use for applications. So one of the applications could be like reverse engineering, where you want to bring in, scan data and you want to produce the parts from those. So you can take advantage of the mesh module with that. Folks, at this point of time, if you have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them for you.